35 meters long, 3 in diameter. Weight more than 200 t. Figures approximate details classified. This object, the most dangerous and most powerful weapon on the planet. For the first time, it demonstrated its capabilities on April 20th, 2022. Well, the long-awaited moment has come. Film crew. Our program turned out to be one of the few who was given the right to see a rocket launch with their own eyes. Film it and more. On Air TV channel star military acceptance. And the main character of our program will be one of those. New products of the Russian armed forces, which has been talked about a lot, but they have never let me film it before. Promising Russian Intercontinental. Sarmat ballistic missile. Let's say right away that this is a new product and one of the most secret. There is very little public information on it, but everything we can, everything we have the right to show and tell. You will see all this right now. Sarmat is the first heavy in the world, intercontinental ballistic missile, 5th generation. They talk about her, what she will become, the most powerful missile in Russia's nuclear account for the next 50 years. They also say that from the Eastern Hemisphere, it can pass not only through the Northern and through the South Pole. That will easily overcome the most advanced Pro system. Today, the military acceptance will tell you if all this is true, and in this issue, all the information will be only from the first mouth awaits you a detailed conversation with the chief designer of the rocket, with deputy commander of the strategic missile force, who directly supervised the launch at the cosmodrom. Finally, with the commander himself. In a word, this program will have more exclusives than ever. So this is a military training. Let's go. What the heck is that? What kind of bullshit is this? Crap, this is crap, this is crap. Military reception on air. Now we are at one of those enterprises where production of armatures began. You can see for yourself that production is in full swing. Soon we will show you the rocket itself. But first, let's introduce you to the man who created this rocket, who has been studying all his life exclusively with missile weapons. This is the general designer. State Missile Center. Vladimir Grigorievich Tar. Vladimir Grigorievich. Why exactly? Your center has been tasked with creating a new rocket. It's not a secret to anybody. The customer chooses the contractor based on performance results. In recent years, I must say that the missile center was created in recent years for it. Missile complex. These missile systems are superior to all foreign ones. Complex, the best rockets in the world. Render gamma sovo perfection. I think that's why. Thanks to these successes, and thanks to that we have technology, which require breakthrough Sarmat technology today. They told us, work to create this complex in the interests of a missile search for Sol to be a destination. We can't talk about all this new for. Let's call the name of one rocket Blue. To date, it's the biggest in the world, intercontinental, ballistic liquid fuel rocket, created for the submarine fleet, and the most efficient in terms of payload ratio, per unit rocket weight. Experience gained in the process of developing Blue formed the basis of a missile system with armature. First impressions when you see this rocket with your own eyes. How big she is. What are the dimensions of Sarmat? In Sarmata, the diameter of the rocket is 3 meters. Its length is about a 14-story building. Rocket mass more than 200 tons. We understand correctly that this is the largest rocket in the history of mankind. Yes, absolutely right. This is the largest rocket in human history. Created in Russian copy enterprises. The biggest battle truth is successful. Out of more than 200 tons of weight, about 180 is fuel. Another 10 trillion payload. That is, the combat unit, easy to calculate, that the rocket body, together with engines, weighs very little. For a 14-story building, materials from which the rocket is made. And the materials from which the rocket is made, mainly made of aluminum alloys. These alloys have shown their reliability. The attraction is that they are light enough and provide high load. In addition to aluminum, their sleeping patterns will also change composition, materials from which the fairing is made, shipping container, and some other designs. Structural elements. Composite materials, first used in the composition, liquid fuel intercontinental missiles. And that's understandable. Until recently, there were no composites. Capable of withstanding decades of chrome plating and incredible loads. Created in flight at speeds greater than Mach 10. By the way, at the altitudes where Sarmat will fly, this is from 8 kilometers per second. However, such speed parameters still need to be achieved. To do this, let's look at Sarmat's flight from zero. Let's pretend it's a rocket. What does starting from the armature look like? Rocket launch is based on startup energy supply. Start mortar. It involves the rocket itself. Transport launch container involved. Cyclorama starting energy device is involved. The next power starter starts. Rocket is pushed out, and at a height of 20 meters. The engine starts above the shaft cut, and these first stages are 200 T, hanging in the air. First seconds, yes, before starting the engine first E, first stage engine. The rocket seems to freeze a step at the launch stop. And after starting the engines, first stage, and it goes on the flight path. To understand how this looks like it really is, let's watch one very interesting video. These are the so-called pro tests of the Sarmat missile. They took place back in 2018. But until then, so detailed this recording on television. Haven't shown yet. Seen Plez's military cosmodrom. Let's rewind this post to the beginning. We see, like on a special reinforced railway platform, cargo is being transported to the testing somewhat reminiscent of a tank. This is a transport container for transporting a rocket. Turns out together with the creation of the rocket itself, solve the most difficult issue of developing a container. Without it, it is impossible to load into the Sarmat mine, and even more so impossible, deliver it to the starting point. Sarmat is transported by two types of transport. By rail from the manufacturing plant to locations, part in which Sarmat will be located. So, we move it with dump wheels, the so-called transport handling unit. We have a system allowing to overload Sarmat from the railway section for pneumatic wheel travel, bring it to the release installation step and download it. That is for this. Special transport vehicles have been developing units, which have been fully tested during throwing tests. How does this happen? The rocket is being loaded onto a road platform with a heavy tractor. On it, our heroine is delivered to the starting point. Here, from one platform on a pneumatic wheel, it is transferred to another. Then a special container. It rises up like a mast, and right above the lump mine. Where do the rockets go down along the guides? In words, everything is easy and fast. In reality, it is a long process. Set the preparation for launch mode. Third first day set. Well, as Gagarin said, in such cases, let's go. Third start, please note. In such a situation, a rocket is used in checkerboard colors. This is done in order so that designers can then determine at what speed did it come out of the mine? At what altitude did the main engine turn on? And in general, how accurately the equipment worked. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket.
which could be used in a rocket. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same mortar launch. This is the same mortar launch, which ensures that part of the energy is saved, which could be used in a rocket. This is the same
I need to explain. A mortar launch is a certain risk. Just imagine you take off in a car. You need to start the engine in flight. There's something here. Yes, of course, it is needed here. Absolute reliability, quite a large volume of mining, which would allow the engine to start in any case. This is the moment. First, the feed block is shot, and then the rocket engine starts. And even though at 18, this striped flight was very short, yes, it couldn't have lasted. After all, the tests are thrilling, but here is historical footage. This is the first start from the armature. Even then, experts understood. What kind of rocket will this be? It cannot be intercepted. Except that such a formulation is impossible. Exactly impossible. Because the remedy. Overcoming against missile KSP. Complex of overcoming. Incredibly difficult, which allows you to pass any. Much mischief. Anti-missile breed. Why is such an interception impossible? Let's figure it out. Firstly, the mass of the rocket plays a role. It provides flight over a very long range. Second, Sarmat has a very short starting flight segment. We'll talk about this later. And now let's focus on the third trump card of the flight path. Fly like Sarmatian. No other intercontinental missile in the world can. Due to the power supply of the new missile system, trajectory has the ability to change from in our notorious trajectory through the North Pole. If necessary, it is possible to lay a trajectory through the South Pole, which is basically not protected today. And there are also possibilities for other trajectories. In terms of conclusions, outer space. In other words, Sarmat, capable of moving not only in the atmosphere, but also in orbit. What does this give you imagine? You built a fence called Pro, and suddenly it turns out that a rocket appeared, capable of flying it from above or from the side. But that's not all. In flight, Sarmat can use hypersonic units, which immediately updates the idea of interception. After all, you can forget about ballistics here. Tennis ball flight. This is a flight along a ballistic trajectory. One player hits, the second bats, and you can play like this ad infinitum. Why, yes, because that the flight path of this ball is predictable. Also, by the way, classic ballistic missiles operate and against rocket. Now imagine that there would be an engine inside this ball. The enemy would prepare to receive the missile, flying along a classic ballistic trajectory. But at the last moment, the engines would turn on, and the hypersonic block would take the ball to the side. Now imagine that this ball does not just change its trajectory. He flies around the table, makes circles. Word misleading. Is it possible to talk about that at the creation of the Sarmat missile system? Russia has found a weak spot about other countries. Missile defense is always under special control. Scientific following organizations of the defense industry complex, and we are dealing with this issue from the point of view of overcoming it. Therefore, those qualities, energy intensity of energy, capabilities of the new missile system, taking into account the combat experience and complex means of coping. Today they talk about it. What for a missile system with? Armada against missile defense does not exist today, since it probably won't exist yet. Coming decades. Today, the strategic missile forces are insert a whole range of mobile complexes. This is Yars Poplar and Poplar. Plus there are mine complexes with the same Yars of Poplars. But with all due respect, all these missiles belong to the light class. Unlike our hero. Look how much. Small man on background. Heavy intercontinental ballistic missile. Now we are at the Academy of Strategic Missile Forces. It is clear that the Sarmat missile is beyond competition, but from all the variety of missiles exhibited in this auditorium, more or less somehow similar to the Sarmat rocket R-36M. I repeat, rocket, like Sarmat heavy class. Yes, you don't need to be an expert here too. Distinguish heavy missiles from all others. The hard ones are the ones which are big, Let's start with this. In what year did we first create our first heavy ballistic missile? So well, the first rocket of this class was created in 1961. Adopted for service is the R-16 missile. Well, this is actually the first two-stage intercontinental missile created in our country, already used on it. High boiling fuel components were used, which made it possible to provide the required high combat readiness. After R-16, the R-36 rocket appears. Then R-36M in Russia, they know it under the name Voivode. In the West, they call him Satan. Before the advent of Sarmat, this rocket was the largest from among the ballistic intercontinental. The governor is also based in mines, even a weight of 200 T. But Sarmat, noticeably superior to its predecessor in efficiency. We cannot indicate quantity and characteristics of rockets, but we can qualitatively compare by picking water. The range of this missile, range greater accuracy. Accuracy is much more accurate. Resistance to external factors is higher. Ability to overcome, significantly superior to analogs. That is, it turns out that Sarmat bypasses the conclusion in all respects. According to everyone, if you think about it, Sarmat is the most powerful weapon ever created by man. Well, let's tell you how and from what it is born. Quite predictable. Rocket production starts from a blank sheet of aluminum. More precisely, a special aluminum alloy. First, it is screwed onto the glass drum. This is how the shell turns out. Cylindrical blank, one of the parts of the future rocket body. Now that the shell is assembled, you need to remove everything unnecessary from it. To do this, you need to solve the following problem. Reduce the weight of this product, while maintaining the strength for this. Take a cutter and put it simply. Apply checkered patterns. Well, to put it correctly, apply waffle background. To show this work from start to finish, using the example of a specific block, we set the camera in filming mode for several days. Neatly, square by square, the cutter cuts off all unnecessary, leaving the perimeters of the squares intact, or speaking in the language of strength of material, stiffening rib. Now, after the food is cooked, they have a waffle background applied to them. It turns out. Next problem. It turns out this circle. She's not a circle at all. It's an oval. The second problem is that this plane as such also does not exist. After machining, a wave appeared here. This wave needs to be removed. Bring the circle to the circle. What to do? Connect the hydraulic forces. That's what it's here for. Special machine for calibrating beads. Strictly speaking, there are no serious problems here. On the machine, an oval blank is turned into a perfectly smooth ring, after which it is transferred to the next workshop. Now we are at the electroplating site. And to be honest, I used to think that all these processes are needed in order to apply a protective film. Well, in this case, to this compartment. But it turns out, what are these cells? Can be created not only by milling, but also by chemical milling method. What is the chemistry of the process of lowering it there? Inside, our product begins the etching process. Well, the whole science is how to do this so that the desired part is etched and the unnecessary one was not etched. It's a secret right now, and we won't talk about it. It is important that in the end we achieve what? Products become lighter. We are losing weight while maintaining strength. Every detail first, arriving here is suspended from the wound. Then a whole series of vans goes through. Water alkaline solution. Water is acidic and so on many times. At all, chemical milling is used for processing very complex parts, where it will not be possible to carry out work using a machine. This method is especially popular for creating parts in radio engineering. But here it is like this. Huge rings of metal are processed in this way. On-air military reception, we still talk about new intercontinental ballistic, rocket with Armada. Now we have a unique opportunity to view this rocket from the inside. The most important thing is what you pay attention to, especially against the background. Conclusion: where is the so-called waffle background inside? It's not here. On the format, the designers decided to take out. This waffle background is here, to the outer surface. We saw an example of how these checkers are cut out. Not only conclusions, in front of you is one of the representatives of the new family, Russian missiles, hangar carriers. These hangars are checkered inside. On Sarmation outside, there is one simple explanation for this. Using this technology, not required. Waste time collecting metal shavings at the stage, production and second complex. Much more important, the coating will be attached to these ribs from the outside and without the roving invisibility of Sarmat. Special materials are used. And not only materials, but also covering, which provides these simple properties. In addition, there is such a so-called tip, which provides. These are all the specified characteristics, and ensure delivery of useful information into Russian. To a given goal, it is he who experiences the maximum temperature. Yes, he is experiencing maximum temperature, which arises during the entire flight of the Sarmat launch vehicle. At least hint what these numbers are. Order numbers A large. Metal melting temperatures, high temperatures, and hypersonic speed. What is important? Sarmat reaches hypersonic speed very quickly. Remember, we promised to tell you about the second trump card of this short boost flight. To understand what we're talking about, you need to understand how any pro system works. Principle of operation, missile defense systems, is the main component. Understand the start time and determine the flight path. So the working principle, any radar station, missile defense systems, lies in the moment of notching. Rocket launch by combustion torch, operation of the first stage engines, and the sooner it is noticed, the faster the trajectory will be calculated, the command will be issued. Anti-missile defense systems, possibility of impact or destruction, one or a new type of weapon. So this is the one, probably a convenient moment of influence, on a rocket with warheads. At the moment of start, when the speed has not yet been reached for. Better understand, let's divide the rocket flight into several parts. First, plot start. Here the rocket picks up speed. On the second, it goes on a ballistic trajectory and flies along it. This is the most stressful part of the journey. It is on it that interception is almost impossible, but still theoretically possible. Third section, finishing. When a missile splits into warheads, we have already noted, Sarmat is invulnerable here. At least because that the trajectory of its warheads is impossible to calculate. But what about the start? One of the tasks is counteraction. This is to shorten the active part of the trajectory, which was implemented today in the Sarmat complex. And I must point out, this is also unique for such a heavyweight. Today is an active part of the trajectory, practically on par with light solid rockets. It's serious how quickly the armature starts. We can't tell, but to at least somehow explain, let's use a figurative comparison again. That is, it's like, in motocross you need to start from a standstill with a whistle, about the same, like that. Is there really nothing like this in the United States? No, there is no such thing. There are no Sarmatians in the United States. They are focused mainly on solid, top topic. And the point is that we simply have the best engines that run on liquid fuel, which still cannot be mastered in production. United States. We'll talk about engines with valves in the second series. In the meantime, it's time to come to the plesetsk cosmodrom, where pieces of Yartsev poplars regularly pass. where a hangar recently flew into space, and now the piece is being prepared. The most powerful combat missile in human history. We already showed her throwing tests, but even they cannot be compared with that. What you will see very soon. Military reception on air. We are now at the famous Plesetsk cosmodrom. By the way, in the world's northernmost cosmodrome, where especially for new intercontinental ballistic missile, built a new launch pad. Sarmat himself is now there. Down in the underground mine. There are a few hours left before it starts, and we have the opportunity. Attach action cameras around the perimeter in order so you can see all the beauty of this launch. 360-degree camera. A whole set of action cameras. We put it all in the riskiest places. We fix it on the nearest masts. Military reception operator, like high-altitude installers, rising higher and higher. We lift well. Very soon footage, captured by these cameras, the whole world will watch. There is less and less time left before launch. Finally opens. Protective device and... Now we can see with our own eyes. The main character of our program. New intercontinental ballistic missile. That's where she is. Inside the mine, let's talk the way again. Which is expected today. If unhistorical, Mascari is definitely iconic and very important. Important because that this will be the first launch after throw tests. That is, the first truly big flight from an Armada. So the last pre-launch preparations remain. And while they go, let's move back to production. This is also Sarmation. More precisely, one of the elements of the third stage. You can clearly see it here. What thickness? Aluminum alloy used for new rocket. In general, projects such as Sarmat are typical themes that, thanks to them, production is completely updated. In front of you, the largest in the country, rolling mill, assembled here especially for the new, promising intercontinental ballistic missile. They say for this purpose, to deliver this design here, 26 trucks were needed. They even built a special workshop for it. The height of this workshop is several tens of meters. But that's just it. What is visible to the eye, a significant part of the service equipment, is located deep underground. Look what... This mill structure has a strong foundation, goes deep underground. Well, on the contrary, we go up, where the main process will take place. In theory, everything is very simple. The task is to turn a flat sheet of aluminum alloy into the sphere, or more simply, to fall in love. Certainly, this could be done using a regular press. But what does the rolling process give? In this situation, we not only change the shape, we are the most important thing, increasing the strength of this alloy. But for a rocket, this is very important. This process is very reminiscent of the work of pottery masters. When they make plates, the workpiece is spinning, and the master carefully aligns the edges so that they become even. Didn't go in waves? Same here. Only instead of hands, there are steel machine heads. And of course, the force is applied during the rounding process. It's incredible here. We have already drawn your attention to the thickness of this sheet. Imagine the load you need to create to bend and stretch such a layer. As required, the liquid you see now, it's clear what it's used for. First for cooling, but it's not water. As it may seem, it's all the thing is. What is the second task? Ensure sheet lubrication. The all collects at the bottom, filtered, and immediately goes to recycling. This is how the sheet of metal acquires the necessary roundness. What can I say? It all looks fascinating. Like the launch of the rocket itself. We are again at the plesetsk cosmodrome, watching the start with a distance of 6 km. The launch is very hard to see from here, but such audibility that everything seems to be happening somewhere nearby, literally right next door. Well, the long-awaited moment has come, and a new intercontinental ballistic missile goes on its first big flight. The starting point is here at the vacuum cleaner cosmodrom, landing in Kamchatka near the Kara training ground. Travel time about 20 minutes. During this time, Sarmat will cover about 6,000 kilometers. And everything else that happens here in the police station, broadcast live to Moscow, to the National Defense Control Center. However, we also have opportunity to view the start in detail. One of our cameras is mounted on a mesh fence, 400 meters away from the tempering shaft. This is the moment of launch. The rocket seems to be jumping out of the shaft, like the jack in the box, and only when the entire body is shown above the ground, followed by a huge cloud of smoke and fire. From such a distance, a 35-meter rocket looks very small. Literally a couple of seconds pass, and she's already reaching the clouds. At the same time, a cloud of smoke, fire vapors are rapidly growing in size, and instantly reaches our camera. And here's what the start looks like up close, this time with a camera located on one of the masts, almost right in the lump mine. And here is one more frame, side view, and here they open for an attentive viewer. New details. Moment of start, not only the mounting brackets are separated, but also a small part of the body. This is the same accelerating block, and it doesn't just reset. At some point, he is specifically referred to small jet engine, so that he doesn't destroy the mine's complex infrastructure. A few seconds after start, the rocket is hiding somewhere above the clouds, and soon everyone who gathered here in Plesetsk receive information from the testing site in Kamchatka. Hit recorded. I confirm the arrival of the product. The rocket passed through the calculated values of the ceiling of the Tartar, exit launcher shaft and flight, in accordance with the specified tactical characteristics. The rocket has flown the set time and set distance. Amazed. Necessary blocks. Our goal was more than chicken, and we now know the accuracy of hitting these blocks. Who arrived? It suits us very well and makes us happy. This is the Kamchatka Territory Kara training ground, the place where one of the warheads hit. This is a crater from the fall of a combat training unit. Armat rocket, simply amazing. Without combat charge, depth 8 meters, diameter 20 military acceptance. I've been to these remote places in Kamchatka. Here's an example of the result of a mace hit. We see that middle-class missiles, like the same mace, and heavy-class missiles, the same Sarmat, leave plus or minus the same mark on the ground. The explanation is simple. Firstly, essentially Volvanki fly to Kamchatka. Combat units would leave a completely different mark. More precisely, they would not have left anything behind at all. And the second, in any of these missiles can be used, or one large combat unit, or many small ones. But now none of that matters. The most important point of impact turned out to be exactly there. Where did they calculate? So today is Plesetsk holiday constructors. Missilemen military representatives, plant engineers congratulate each other. Probably the same as in those very days, when Gagarin flew into space. Vladimir Igorovich. Congratulations on behalf of the Star TV channel. It's just incredible what happened. How many years did it take to achieve this victory? Exactly 9 years ago, we received tactics. Siberian mission 2. Development of this complex. And here is the first real tangible result. Flight tests, the pinnacle of many years of experimentation, before this in dozens of laboratories, scattered throughout Russia. Checked functionality multiple times. Each of the nodes of the Sarma rocket. Stage separation, block separation, turning engines on and off. And only now can we say, everything worked out, and it turned out as planned. Deputy Commander of the Strategic Missile Forces says in the next half-century, Sarmat will be the most powerful missile. Country's nuclear account. This is a perfect rocket launcher. Who will stand on combat duty for the next 50 years? You say that, this combat complex will be relevant for at least 50 years. What gives such confidence, and what will happen next with the reinforcement? Gives such confidence, first of all, embedded low-performance tactics. This rocket was manufactured only on components. Russian production Great reliability is built into this missile system. This gives reason to think so. And also, the basis for such statements is the preparation, which is led, strategic missile forces. Plus to this, mass production of new missiles has already begun. Was signed in 2019 by the Ministry of Defense. Big contract with State Missile Center named after Makiyev. And most importantly, in the near future, Sarmat will go on combat duty. Infrastructure is currently under construction. Personnel from sergeant to division commander, for productions and on duty. Sarmat Missile Complex, already this year, in the Luzhev Missile Formation. The most important thing is that all this will happen this year, already, all this year. Remember a few years ago, when the Supreme Commanders first expressed that the country will be armed with such powerful and breakthrough weapons. Many smiled, calling all this fiction for a fantasy movie. On April 20th, 2022, the world understood this is a documentary. Well, let's add from ourselves. Almost all of these beautiful shots, which were broadcast by the planet's TV channels, were filmed by cameras from TV channel Star, and largely through the efforts of operators in military acceptance. Why does the Sarmat missile system have such a name? Sarmatian ancient warriors, who were fearless. They created heavy cavalry, having the expression of a long, heavy spear of arrows. And most importantly, there was a straight-cutting sword, who instilled fear in his rivals. And always before the raid they thought that at the expense of this sword they will receive retribution. Probably the quality of our modern missile system today allows us to talk about this. This could be the sword of vengeance. This is what warns about it, that Russia is reliably protected. This is not the end of the story about Grozny Sarmat. In the next issue of Military Acceptance, we will continue about the new strategic missile system. And believe me, it will be no less interesting. We will visit a closed design bureau. Where are nuclear missiles developed? Let's get to the classes of those officers who will be on duty behind the Sarmatovian red button. Let's go to the active missile unit of the strategic missile forces. And not only will we show how and where rocket men serve, but we'll also climb deep underground to the command post. And the most important thing, we will tell you a lot of new details. Not only about Sarmat, but also about another, the newest complex of Russian nuclear deterrent forces, Vanguard. So wait. See you in a week.